Coach Meeks from St. Mary's Correctional. Welcome back. I'm here with some of my friends from OIEP. We're working on, again, we're continuing with our series on helping develop some math concepts. At this point, hopefully you've already videoed or viewed a video and your students are aware of what slope is and what a linear equation is. What I'm wanting to develop now is the concept of functions. The new readiness test and a lot of the tests for the high school equivalency diploma is taking us more into Algebra 2 and higher level skills, and so I want to try to simplify the concept, and in doing so also look at 4, 5, or 6 different problems, sample problems, and ways that a student can be tested in their understanding of functions. And when we're done with this video, hopefully it makes you a little bit more comfortable sharing it with your students or teaching it yourself. What's a function? Formal definition: a function is a special relationship where each input has a single output. It is often written as, and you'll see this, f of x. I'll tell my students I just consider this function, and where x is the input value. Coach, what's that in simple terms? Well, an example of a function that that you may know already or should have covered is a linear equation. By definition, what is a linear equation? It's an equation or a problem that defines where a line is on a graph. Okay? And what I teach my students is, and here's an example of it in slope-intercept form. There's my slope and there's my y-intercept. And what I teach my students is that the equation is the map of where whatever I'm graphing is going to be. And the second thing I mentioned to them is that every ordered pair that keeps the equation true, in other words, is equal, is a solution, and that every solution can be written as an ordered pair. Real simply, when I graph something, normally we go over x on the x-axis, and so every ordered pair, you have an x value and a y value. A little quick reminder for my students, I always tell them, they get confused whether I go left or right or up and down first when I graph, so I always tell them that the alphabet, you read from left to right, and x comes before y in the alphabet, so it reminds them that x comes before y when you read, so x comes before y in my ordered pair. Just a little trick that I help so my students don't get it backwards. But what do I mean that every solution is, every ordered pair is a solution, and every solution can be written as an ordered pair? So let's take and look. I have some ordered pairs that were a solution to this equation or function, and my x value is 3, so I'll put my x value as 3. And if I work the problem out, 1/3 of 3 is 1, and 1 plus 5 is 6, so then my value for y should be 6, and as you see, that's so. So in other words, this ordered pair, when I put the x value in and the y value in, it's true. Okay, and that's what I mean by it is a solution, and that every solution can be written as an ordered pair. In other words, here's some more functions, examples of functions. Here's a parabola or a quadratic. For your students, you'll see some kind of problem with an x square term, and again, it could be a trinomial or longer. I'm not really here to talk about that, other than here's a graphing of a parabola is a graphing of your quadratic. And what I mean by every solution can be graphed as an unordered pair, in other words, every point touching, if you go map it, find where the x value and where the y value is. And so in this one it's 1, 2, 3, and up 2. So this point is 3, 2. Then I know going into whatever equation that would have been for that parabola that it would work out and it would be true. If you find a point in the problem and it doesn't land on the line somewhere, then it's not a solution. and then you would know that wouldn't be your answer.
Hey, Coach, what about the vertical line test?
A little thing that I teach my students to try to help identify whether something is a function is, remember I said for every input or every x, okay, I have a single output. What I mean by vertical line test is I can slide across, and my vertical line will, as I go across my x values, each x value, I will only touch my graph in one spot or have one output. Here is a linear equation. As I slide across, for every x value, I'm only touching the line in one spot, so I have one y value. So the trouble with this is these are all functions. So what's something that doesn't look like a function? Well, what if I have a parabola that's sideways? Again, it can be graphed in geometry, and it may show up on a test, but as I go and I come across and as I find that my x value is 0, I find out that I have two different y values. So I can go to 0, 5 or 0, negative 7. And so because I have two different outputs for the same x value, then it would not be a function. Another example might be something that looks like this. Again, as I slide across the vertical line test, I am touching two y values for the same x, and it would not be a function. So a little quick test for some of those that like to be hands-on or visual to try to understand what a function looks like. A common question you'll see, they'll ask whether or not an ordered pair which graphing, would represent this ordered pair. This is a little bit easier. Remember I said that every ordered pair is a solution. So in other words, I should find each one of these on my graph. Remember, xy, xy, xy for some of my students that are learning. So I'm going to come over here, start at my x. I'm going to go over 2, 1, 2, up 3, 1, 2, 3. And so that point's there. I'm going to go over 3, 1, 2, 3, up 2, 1, 2. That point's there. And then I'm going to go over 4, 1, 2, 3, 4, up 3, 1, 2, 3. So that point's there. All three of these ordered pairs lands on the graphing of that parabola. So yes, these would be part of the solution, or this graphing would be my answer. Just to double check, because I don't want to say, well, maybe I got lucky in A. You want to see what I'm talking about? Let's come over here. Let's go over 2, 1, 2, up 3, 1, 2, 3. And that ordered pair does not land in the line. So therefore, that ordered pair is not part of the solution. So that's not a graphing. So that those ordered pairs would not be part of the graphing of the solution or answer for this test. Yes, sir.
Do we need to go on and check in the other since that one doesn't fall in the line?
If you want to waste time, yes. But remember, on the readiness test, time is a factor, so I'm moving on. Okay, again, which of these sets of ordered pairs is a function? And now you see several ordered pairs. Let's go back to my original definition. For every input, there's an output. So for every x value, okay, I can only have an output or one y value. So I'm going to come through here, if I have to, say xy, 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 xy. Or sometimes I just have my guys mark the x's, because that's what we're going to check. And I look here, and there's my x of a 7. Here's my x of a 7. And if you notice, there's two different values or outputs for y. Not a function. Remember my vertical line test, that can't happen. So I come here, negative 4, negative 3, negative 2, 4, 2. Every x value is different, so there's no possibility of having two y's for the same x or two different outputs for the same input. So I'm done checking. All right. Just so you know what Coach is talking about. 3, 4, 6, 5, 6. If you notice, I have two x's that are same, and the outputs are different, not a function, and you'll find that problem again with this one. So just moving on, like I would in the test, once you realize that for every x value, you don't have a different y. Coach, what happens if I have different x values but the same y as we did here? That's okay. Remember, I have to have a different output for every input. It doesn't say that I can't have the same output value for different inputs. Okay, welcome back. Still working and continuing on working some sample problems or types of problems you might encounter. It's going to check your students' basic understanding of functions. Which of these sets of ordered pairs listed below will correctly satisfy the equation y equals 3x minus 1? If you remember me saying, and you can hear me say it continually throughout, that an ordered pair that meets the requirements, that is a solution, and that every solution for a problem can be written as an ordered pair. And so I'm going to work some examples and show you. So often you'll hear other students or teachers say, if you're when in doubt, try C. So I'm going to try to get a little bit coy, and we're going to jump in and try C right away. So, with that understanding that an ordered pair is a solution, and I want to find out if it meets the requirements, I'm going to begin with this first ordered pair, x equals 3 and y equals 8. So it's going to be a little repetitive, but I'm going to have to work this problem a few times. So I have y equals 3x, so 3, and I'm going to put in this 3 value for the x, and finishing writing it. Okay, 3 times 3 is 9, minus 1 is 8. I come down and check, and yes, that's what the y value is supposed to be. So that ordered pair works. Let's look at it again then. Again, we have to check each ordered pair and make sure it's a solution. So 3, this time I'm going to plug in the 4 for my x, minus 1. 3 times 4 is 12, minus 1 is 11. And I check, and my answer should be 11, and it was, so that ordered pair works. And finally, one more time. 3, my x value is 6, times 6, minus 1. So 3 times 6 is 18, minus 1 is 17. And I plug it in, and I come over here. Oh, they're trying to trick me. And that's not an uncommon event that you might find on a test. So what this means is, don't get satisfied with just checking 1. If they put 3, you need to check 3. Not very often will they do this, but in this case, you see, if I'd have got a little rambunctious and tried to speed up too quick, I would have missed. So now the only thing I can do is keep repeating the problem and checking with different ordered pairs. So I'll come back up here and we'll try A. Okay, so my x value on the first ordered pair is 2, so I'm using the same equation. 3 times 2, okay, is 6, minus 1 is 5. So when x is 2, my y should be 5, and I come up here and check, and that's the case. And we'll just keep right on along. 3 times 3 minus 1 is 9, or 9 minus 1 is 8. And so the y value should be 8. And again, we know that. And then finally, let's check the next ordered pair, and I'll do it here. 3, the y value is 7, minus the 1. So 21 minus 1 is 20. And I check, and now the y value is 20. So in this case, all three of the ordered pairs are a solution. So this would be my answer for this equation on the test. These 3 ordered pairs are all satisfying it and would make this a function. Continuing on. Another possible question. You'll see for the function f of x. The first thing that I notice is, oh, coach, watch this. That is the way in algebra that we'll write. In other words, you don't have to check. You don't have to check and see whether or not this equation is a function. You know it. Right? That's the way that we mathematically indicate that it is a function. In other words, graphing in this would pass the vertical line test. Okay? That's not going to really, other than that information, that's not really going to help you solve it. What I teach my students is to think of this as, change the f of x and think of it as y equals 2x squared minus 3x plus 6. And I'll have my students rewrite the problem so that they understand that an X and a Y. And remember, where does the X and Y come from? The X and the Y comes from your ordered pairs. You're going to come find out where your X is and where your Y, and every solution is written as an X and Y value on the graph, so we can map it. So I have my students rewrite it, and that makes a little bit of sense to them. And now, what is f of 2? The little shortcut that I tell my students is this. What did I replace with a 2? And as you can see, that I replaced the X with a 2. And without getting real complicated, that's what I tell my students to do. They're asking you to find the solution when X is 2, or I'm going to replace the X in my problem with a 2. And so I'll simply do that. Everywhere I find an X, I'm going to go replace it with a 2. And now I'm ready to solve. Okay. 2 squared is 4. And I'll just keep rewriting my problem. Following order of operations. And now I got rid of my exponents. Now I see multiplication and division. Yes, I have multiplication. 2 times 4 is 8. Continuing on, 3 times 2 is 6. And now I can finish my problem. 8 minus 6 is 2, plus 6 is 8, so y equals 8. And showing you an example of a gridded response problem that you'll find on the test. You can write the 8 in, or you can write it at either end, and then make sure you bubble the 8. Okay, Coach, what if I have a problem? What if I have a problem that looks a little bit uglier? In other words, I'll work a problem. I'm going to use the same equation, but this time I'm going to say f is 3.1. And this would maybe be an example that would be on the calculator version of the test. What changed? Well, first of all, I still see f of x, so it tells me that it is a function. So I can say y equals 2x squared minus 3x plus 6. And now they want to know, what about f at 3.1? In other words, what is y if x is 3.1? And so I'll have to come in here. Put 3.1 in. And no, I'm not going to try to impress you. This would probably be on the calculator version, so I tell my students, take the time and get it right and use your calculator. So I'm going to do 3.1 squared. Okay, and now that's 9.61 times 2. And this all becomes 19.22. Okay, subtract 3 times 3.1. Subtract 9.3 plus 6. And so 19.22 minus 9.3 plus 6 equals 15.92. So now here's one that's not so nice and neat. And so we're going to go 15 point, and we'd have to round to 9 with this response. If we had another spot in the box, we would put the 2. And then you would bubble in 15.9. Okay, so an example of how you do a gridded response, and also an example, common example of how they're going to check and see whether or not you understand a basic function question. Okay, a few more examples and we'll wrap up this on functions. here's an example. They're asking me to fill in the table for f of x, so we know that what? Y equals the absolute value of x. Okay? And fill in the table. Well, they tell me that my x value is -4. And so I would put in -4. And what is the absolute value of -4? That's really used for distance. In other words, I don't care whether I'm going south, negative, or north, positive. If you walk 4 miles, you walk 4 miles. So that's really why absolute value, one area where absolute value is used in the real world. So how far did I travel? So we ignore any signs, and y would equal 4. Okay? And then we would just put every value of x in. So what is the absolute value of -3? 3. The absolute value of 2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of +1 is 1. And again, 2, 3, and 4. And if you would graph this, you would see 0, 0, 0, 0. And then you would go over 1, up 1, go back 1, up 1, then we would go over 2, up 2, and it would end up looking like a V, and that's the graphing of an absolute value function for this problem. Would it pass my vertical line test? Yes, as I slide across, it would. So that's an example of a function. But based on my question, they're asking which values would be the result of my problem. And so as you can look, I would need the answer up here that goes 4, 3, 2, 1, 0, 1, 2, 3, 4, and that is satisfied by A. Okay? Okay, another problem that you might see, and that understanding the idea of a function will work. You'll see this covered, this type of problem is covered. Here's a couple linear equations. Both of them are in standard form. Again, you need to watch our segment on slope and linear equations, and we'll also have other teachers talk about using substitution and elimination methods for solving systems of equations. But I'm wanting to show you where understanding the concept of a function and that every ordered pair is a solution can make a problem like this a little bit simpler. I wouldn't want to really call it a shortcut because you do need to understand substitution and elimination method, but understanding here, so they're asking me to solve a system of equations. In other words, here's a linear equation. It might help if I rewrote it for you in slope-intercept form. In other words, I'd like to get the y by itself, so I'm going to jump that over, and the opposite. When I jump over the railroad tracks, it becomes negative. And so that equation would become y equals -2x plus 6. And again, I want the y by itself, so I'm going to jump this over the railroad tracks, and I would have 4y equals -3x plus 4. And to get the y by itself, I've got to divide by 4. And so then this becomes -3 divided by 4x, and 4 divided by 4 is 1. So I rewrote the problem. Again, that would be under a section dealing with linear equations, but and hopefully you would understand how to do that. Don't get caught up in that, but I just wanted to show you that there's other segments. If you don't understand what I just did, there's other segments that you need to be reviewing to help you prepare for this test and your high school equivalency diploma testing. All right, so now I would have two problems that are linear equations, and they're asking me to solve for the system. In other words, where do these two cross? And where's the one point that is an answer to both of them? Okay? So remember, I said every ordered pair is a solution. So let's just start off and plug it in. And you can either use these equations or the ones that I converted to slope-intercept for those of you that prefer to look at it this way. But I'll go ahead and use the original problem. 2 times 1 is 2 plus 5. So that is 7, and that's not what I came up with. So that's not a solution. So I know that can't be. We'll go to the next one. 2 times 2 is 4. Plus 7 is 11. That didn't work. I'll go to C. Two times 3 is 6. Plus 1 is 7. That didn't work. So obviously, hopefully, we're going to find an answer here. 2 times 4 is 8. Plus negative 2. We'll take away 2 is 6. And D would be the answer. Remember, I'm solving for a system, so it must be true in both problems. So let's plug it in over here. 3 times 4 is 12. Plus 4 times negative 2, which is negative 8. And 12 minus 8 is 4. So this answer does solve both equations, and therefore is the answer. Just a little shortcut instead of having to use substitution or elimination. And finally, here's a unique question. Let's see what it's asking. Consider this system of linear equations. Okay. Which is the value of A if the solution of the system is 5, 1? In other words, like the problem I just worked, they're telling me that my answer, where these two lines cross, is at the ordered pair 5, 1. So I know that the X value must be 5 and the Y value must be 1. But they're asking me to find the value of A, which is in this problem. So let's say A times the X value is 5. I know that because they told me this was my solution. And minus 5 times my Y value, which was 1, equals 15. And now this becomes A times 5, or 5 times A. Minus 5 times 1 is 5, equals 15. And now we're just going to use algebra, and you'll hear me use some language that you can watch or ask me about in other videos on 1-step and 2-step problem solving. And I'm going to go to algebra is the land of opposites, so I want to untangle the A. So I'm going to cover up the variable, and I have a negative 5 on this side. The opposite of negative 5 is positive 5. In other words, if I owed someone $5 and paid it off, I would owe them nothing. And that leaves me a 5A on this side. Remember, the equal sign means my scales of justice are balanced. So what I do to one side, I must do to the other. So I'll add 5 to this side. So now 5A equals 20. And the opposite of multiplying by 5 is dividing. So I'll divide both sides by 5. And my solution here is A equals 4. And it's C. So again, I did not use substitution or elimination. That would be hard because it was already done for me. I would have to understand the concept of a function, and that if the ordered pair was an answer, and just plug it in looking for the variable or the term A that they were looking for. So a little bit more advanced problem, but again, after watching this video on functions, hopefully you would have been able to recognize and cut through the chase and understand what they were looking for. Again, Coach Meeks, St. Mary's Correctional Center. You can contact me at work if you have any questions. The number there is 304-684-5500. My extension is 315. Or you can contact other members of the math team. And again, we'll have that available in the credits of this video. Thank you for your time today.